So now we are going to do the parquet files ready. So now this is the Python file we are using to interact with PySpark. So in this one, if you look at that, we are accessing NFS. We create a parquet files in the cj_nfs yarn location. Let us check it out before we use this. Make sure that that folder is accessible. So these are the parquet files are there. And same here, again we are going to run with the 6 node and same Spark directory and folder. So here we are going to change the file which we are interacting with by Spark. So here we are going to interact with this PySpark program. As usual, same thing, we are going to collect the endmount through this program, through this script. The same way we are going to run the statistics so periodic. We are collecting, communicating with the A800, and then this is the PySpark program. We are going to interact to do the reading operation. Cluster, whether a cluster is ready, Hadoop cluster. So all Hadoop clusters are green signs. We have 6 nodes and 6 worker nodes. Nodes are working fine, and a yarn server. So we have 6 servers also working fine in yarn. And let us check it out, the resource manager interfaces. So here we are running 6 nodes. So all nodes are running with the 240 GB memory and 40 cores. Currently we do not have any applications are running. Let us run the applications now. So we are going to run the application. We are going to run the run test demo program using hub. Okay, so we are running that now. Let's tail up the file. So now we are clearing the cache here. So we are having the clear cache program within that demo. Run test underscore demo.sh file has the clear cache script. Okay, so now the query is, so this is the query we are running. This is the location we are running, going to read. So SparkSQL, SparkSQL query using PySpark is running here. It's going to start now. So application manager is running here. Let's check it out in the site. Yeah, so the new applications came up here. So the process also running in the background. Application manager is ready. And then let us check it out, the reading operations. So here so it's going on now. So because we are using cache count, so it's doing the caching details here, and then stages of the query is in progress here. Resources, servers utilization, 6 nodes here. All the cores are used here on the cluster. So it started here. So almost 100% used. Just before I ran the this one is at the time of write operations I ran. So that time also it used almost 99% of CPU. So throughput is disk IO, throughput is going up. And let us look at the storage throughput. See here, storage is, first we start with the 4.6 GB, and then here it's again it goes to 3 GB. It's gradually is going up now. Let us look at the Mpio State. So ideal is almost 99% is used. It seems like all the servers are completely busy. I'm just checking one of here. If you look at that utilization on the storage side, it's gigabytes per second. Data send is more than 1.5 GB. It's going on. Let us look at the CPU utilization. Almost all the CPUs in a particular server. I'm just looking at the server file. If I look at this Mpio State, 99%. Almost most of the CPUs are used here. The job is in progress. The storage throughput also is going up. We are going 1.7 steady. It's spiked at 4.6 and then gradually it's going up here. Let us look at the cluster utilization. If you look at that here, almost CPU 100% is utilized, and then cluster disk IO 4.7 it's going on so far, and then cluster network throughput close to 1.5 gigabytes per second is going on, and we are not using any HDFS file system for data read and write, so that's why it's just 100 KB. Storage as in perspective close to 500 GB is done. That means 2 out of 2.4 terabytes, almost 20% of the data is completed. The file system, here we mounted multiple IPs, single mount point. So this is the network utilization, the storage utilization on the storage side. We are running statistics so periodic command here. So if you look at that CPU utilization, some of them using 100%, most of them more than 90%. So we are almost completed 50% of the load. Spark job completed as 10,000 jobs, 10,000 tasks are completed, RDDs are completed, 10,000 RDDs are completed. Storage perspective, close to 1.2 terabytes completed, 1.281 completed so far. I just want to show here for the temporary space for the node yarn node manages local DARs. We are using the ISC LAN. So here we are using yarn node manager local DARs to pointing into a couple of ISC LANs. So you can also use fiber channel or local disk for better performance. Resources here. So here, look at that. 100% close to 100% is utilized. 95, 96%. And this IO is 4.7 gigabytes per second is going on, and cluster network IO is going on close to 1.7 gigabytes per second. So close to 13,000. Storage utilization close to 75% of the job is cached. count is cached here. So now that the caching part is done, storage perspective, we can see that 2.3 terabytes of data caching is done here, and the filter group by query is going on now. So let us look at the storage utilization at that time. See here, because it's cached most of the data and the storage side is not utilized any disk IO throughput, almost zero. And let us see in the storage side here. So here also it seems like it's coming down. Let us see after a couple of minutes. So here, but in the disk IO, look at that, the throughput is increasing. Same thing on the cluster network IO, it's gradually increasing now. Let's wait and see. Okay, let us look at the Mpio State on the storage server side. IO weight close to 30% here on all the servers, and idle is 20% idle, and because it's trying to use the cache data. And in the storage side, it's consistently retaining the data send is 1.9, 1.5 to 1.9 throughput. So here also coming up 2.08 throughput. So if you look at here, in this case idle, CPU is somewhat idle is there, but most of the CPU utilization is used, some of them for IO wait, some of them for used for the user process. Here it seems like CPU utilization is not much for this filter query, because this is based on the cached data. But this IO, it's pretty good here. And then network throughput also, cluster network throughput also gradually increased here. So here jobs status, almost 6,000 jobs tasks are completed. Here only 50% of the CPU is utilized, and network is coming down. That means the job is about to close. Here are disk IO, cluster disk IO, it already came down. That means the job is almost done. Let's look at the Mpio state. So most of the CPUs are idle now. Storage side also almost free, and all the CPUs idle here in this server. And then the job is almost about to complete. Yep, it's completed. It's completed the entire jobs in 37 minutes 26 seconds. Let's check it out, the finished operation here. This one is finished operation. 37 minutes 20 seconds is completed. Yeah. So let us look at the Nmon results for this. Let's go. So based on this here again, almost percentage is full. See summary. Let's see all. So almost 100% is full.